All right. Continuity versus resistance. What are the differences? Okay. Um, you may see both symbols, ohms and continuity, on the same setting, depending on what type of voltmeter you have. Now, continuity is going to be a very low resistance, probably less than a few ohms. You're going to hear a tone, some kind of audible sound of some sort. A lot of technicians, like myself, like to use this setting if you got your hands tied and you can't really get to see the screen of the voltmeter. You go by sound, a very good way of checking out your boards, your circuit boards and what have you. So you can use continuity. Resistance is just what it says. It's the characteristics that make a component fight current flow. The bigger the resistance value in ohms, the more it fights. So you're going to have a higher resistance like in your start windings as you would to your run windings because of the size. It's going to be restricted. You're going to be a lot more resistance. Okay. All right. Let me see what else I want to touch on. Again, don't hang your hat on this. Some of these graphs I put in here. One size is not going to fit all. All these meters are going to be differently, though. The other thing I want to point out to you before we get started is, and I know you all know this already, but this is the ohm symbol. Think of the upside down horseshoe, if you will. Okay. Here we have AC voltage. Here we have DC voltage, alternating current, and direct current. Okay. Single phase scroll compressors. That's what we're going to touch on first. All right. And the way I'm going to do this is I'm not going to identify the pins on the compressor. The situation is this: we're going to walk up on a compressor and for whatever reason, whether it's single phase or three phase, it doesn't have the common run or start on it, or T1, T2, T3. Okay. So the first thing we want to do when we're checking the resistance on the compressor is get the power off. We do not need the power on, and we want to remove these wires. All right. Again, setting on your voltmeter is going to be the ohm setting. Okay. If you're using ohms. Now, single phase scroll checking the resistance. The graph is showing us from the top pin on the left to the bottom pin, and what it's telling us on the meter is we have 11 ohms. You want to document this. Whatever you get, document each pin. Draw you a little diagram and document those out, okay? So from this pin to that pin, we have 11. From this pin to that pin, we have 4. And from this pin to that pin, we have 15. So we had 11, 4, and 15. Now, a single phase scroll resistance. Let's take a look at this in slow motion, if you will. Let's walk through this very slowly. So basically what this is saying is from your common to your run, whatever that total is, and your common to your start, you add both of those together, and that will be the equivalent of whatever you have between run and start. Okay? So in other words, whatever common run is and common start is, it's the equivalent of whatever you get, the total of whatever you get between run and common, or pardon me, run and start. This is just a little diagram I drew out on my desk here. Don't hang your hat on where these are at. Your start might be up in this, up in this corner, and common over here more than likely. It's just really the formula we're focused on today. Okay. Now I'm going to put some numbers in here, and we're going to try to figure out which one's which. Okay. Remember, our total from run to start is going to be the equivalent of this. So we would assume this is our run and start, the 15 ohms. And next would be our highest resistance would be our common to start. And then we would assume that this is our common to run. Okay, let's see if we're correct on that. There's our common, there's our run, and there's our start. So that worked out right. Common to run, 4 ohms. Common to start, 11 ohms. The two totaled comes up with 15 ohms. Now, this might not be exactly 15. It might be 14 point something. It might be, going back and forth a little bit, but you get the gist of it, okay? It's going to be fairly close, if not exact. So we're checking the resistance of it. And the moral of this story is we have a good compressor here. Let's look at something if we don't have a good compressor. Now, on this drawing, I drew out that there was a break between common and start. What does that look like on our voltmeter if we're ohming this out? Okay, so what it's saying is from common to start, we're going to be OL, opened, all right? And from start to run, we're going to be opened, right? because we're going from start to run. We can't get across there back to run. But from common to run, we're going to be okay. We're still going to have that original 4 that we have. Okay? Let's try one more. Inherent protector. What about our inherent protector? Where is it located at? Now, this falls in those categories of NFF, no failure found. And I want to make you aware of this because this is a very common mistake a lot of people make out in the field. This protector is right here between the windings and the common. So we have an open, if that inherent protector that goes off on high heat or high amps is open, it opens up, it can give you a look as if the compressor is bad. So what might that look like on your voltmeter if you're out there diagnosing it? Okay. So what it's saying here is from common to start, we have OL, we're open. From common to R, we're also open. But from run to start, we have our original 15 ohms. Okay, so keep that in mind. Is the protector open? Is the compressor too hot? Something we need to look at. Have we ruled out that it's too warm or it's been running for a long time? Do we need to walk away from it for a while? Do we need to run some water over it? Do we need to pack some ice around it? These are things you need to be running through your head, but make sure you're aware of that inherent protector, which means nothing more than it's tied into your windings, okay? And again, it goes off on high heat or high amps. Now, I did this diagram. It says single and 3-phase scroll. We're going to check shorted for ground. Notice I put the common and T1 together, the start and the T2, and the run and the T3. So whether it's a single phase or a 3-phase, a grounded compressor or compressor short to ground means that electrical winding inside the compressor has broken and hit the side of the compressor. This causes a direct short to ground, igniting the oil and causing a burnout. The first thing I want to point out, very, very important, find you a nice place to get a good ground and clean that surface off. In this picture, which I like, I pulled this off the internet, just an image. Clean this up. He's making a good ground here, okay? So we should have, if in a perfect world, we should have open all the way around it, okay? OL, all right? We're going to take start or T2 to ground. We're going to take run or T3 to ground. And we're going to take common or T1 to ground, depending on your phasing, okay? So put one probe on each one of those pins individually and go to ground over here as in this picture. And you should have OL in a perfect world. 3-phase scroll resistance and ground. Here we're checking resistance. On 3-phase, all 3 phases should be the same. You should have, and I just threw these numbers here, don't hang your hat on that, they're not sketched in stone. From T1, T2 in this example, you have a 0.68. From T2 to T3, the same thing, 0.68. T1 to T3, you're going to have a 0.68. Now, again, these could be close or exact, okay? So don't hang your hat on these numbers or the numbers I wrote down here. These are just examples. The reason I put this in here is where can we help ourselves out? We're going to do a little film here on the amp draw. I'm going to actually do a live film on that. This is just some PowerPoints I put together for you. First of all, we can go to Copeland Mobile under the diagnostic area. I just picked a scroll compressor out. There's no rhyme or reason for that scroll. Threw some suction numbers in here. I can tell it's a high application. So for air conditioning of some sort. So I just threw some numbers in here. Again, I just kind of fudged them in. You got 75 on the suction, 290 on the discharge, actual current draw from the compressor. I put in there 6.7. The voltage we're going to say is 220. I hit calculate, and then you can see my numbers down below. But don't forget, when you're working with our electrical, use the Copeland Mobile. You can check your resistance. You can check everything you need to know in that electrical section. Everything we're doing today, you can check on that Copeland Mobile, all right? Real quick, not all that important, but I think it's important enough to go over it. It's something that you should know. You may not use it every day, but this is Ohm's law and the formula, okay? So the way I was taught on this is put your thumb over. So this is voltage, all right? The I is your amps. And the R is your ohms or resistance, okay? At the bottom, I identified them. V equals voltage or volts, I equals currents or amps, and R equals resistance or ohms, okay? Put your thumb on the R, okay, and block it out, All right. What it's saying is volts equals amps times ohms. I times R. This line will be a multiplier. All right. If you're trying to figure out I, you're taking R into, think of it as a division problem. R, the volts is above your ohms. So you're dividing the ohms into your volts. All right. And that's how you get the current or amps. All right. So you've got your ohms divided into your volts equals your amps. Same thing down here. R, there's our ohms. It's the equivalent of, again, think of it as a division problem. We got V over I. Our amps divided into our volts equals our ohms, okay? And here I just put out a little formula. You can see the 12 volts here. They're wanting to know what the amps are, and we've got 4 as the resistance or your ohms, okay? So it's 12 volts divided by the 4 ohms equals, the answer is 3 amps, all right? I just wanted to touch on that a little bit. I know you're not going to use it every day. You may not even use it every month, but it's good to know. All right, that's it from this presentation. I appreciate your time, and we'll go to another camera and check out pulling some amps on a live compressor. All right, I hope you got something out of that. Again, I'm Don Gillis. That's your Fun Fact Friday for today. If you're on call, be safe out there today. Please share the knowledge, and I will see you next week more than likely. I hope you all enjoy your weekend and have a great day. Take care now. Bye.